Okay, here we have a little chain rule problem. We're going to differentiate this 2x minus 1 cubed. So let's let y equal 2x minus 1 cubed, and also let's let u equal 2x minus 1, and this implies that y, therefore, if u equals 2x minus 1, then y will equal u cubed. Let's have a look at that and see how that works. All ties in together. Let's highlight that. So therefore the 2x minus 1 is equal to u. So therefore we've replaced this 2x minus 1 with u to get u cubed. Now what we do with the chain rule is then differentiate these two substitutions. So we find du by dx and we get 2. 2x minus 1 differentiated is 2. The gradient of this, if you think this is a straight line, we know this is y equals mx plus c. We know the gradient of that is 2. It's the m bit. Let's find dy by du now. So differentiate this with respect to u. So dy by du equals times by the power 3, take 1 off the power, squared. Now the chain rule states that dy by dx equals dy by du times by du by dx. So therefore we're going to do this times this, dy by du times du by dx. In this case that will equal dy by du is 3u squared times by 2. So we're going to get 6u squared. But as we saw earlier, u is equal to 2x minus 1. So let's replace that with 2x minus 1. So we're going to get 6 open brackets 2x minus 1 all squared. Now the next part of the question says expand 2x minus 1 cubed using the binomial theorem and then find the derivative of that. Well, let's do that. So 2x minus 1 cubed using the binomial theorem. Now if you can remember the binomial theorem, we're going to do nc naught. N is going to be 3, so we're going to do 3c naught to get the coefficient, and we're going to do 2x to the power of 3. Always do the first term to the power of the highest power, n, times by the second term, which is minus 1 to the power of 0. If you can remember, whatever you always start off at 0, and whatever this number is here gives you the power here, and then you find the power here by subtracting 0 away from 3, so that will still be 3. So now we increase this 0 by 1 to get the next term, 3, 1. So there's no need to remember for any formulas, just do this. Oops, sorry about that. I didn't want an equal sign in there. Let's just grab the rubber and rub this out. And I still haven't got the rubber. There we go. Let's get my pen back and carry on. So what have we got? 2x cubed. Now we're going to raise it to a power, which is the difference between these two numbers. So that's squared. Times by minus 1 to whatever the power of this gives me 1 plus 3, 2 times 2x to the power of the difference between these, which is 1, times by minus 1 squared, and the last term, which I can't quite fit on the end here, is going to be 3 times by 2x to the 0. And the ones that you've done this quite a lot will be able to quickly go straight to the next line and not have to write this all out. But I thought I'd show you how you write out the whole expression and to make it easier for you to remember in future. So let's give ourselves a bit more space to write the next line. So equals 3 naught is just 1 times 2x all cubed, which is 8x cubed. and minus 1 to the naught is 1. Anything to the power of naught is 1. So we're just going to get 8x cubed for our first term, plus 3c1 is 3, times by 2x squared. 2x squared is 4x squared, so 3 times 4x squared will give us 12x squared, and we've got a minus 1 there, so we've got minus 12x squared. I was a bit premature putting that plus in. Now the next one, 3c2 is also 3. 2x to the 1 is just 2x, so that's 3 times 2 is 6, times by minus 1 squared, which is 1, so I'm going to get plus 6x. Now minus 1 cubed is minus 1, 3c3 is 1, 2x to the naught is 1, so all of that is going to be minus 1. Right, let's now differentiate this. Just going to have a bit more working space again. So therefore, if we differentiate this, so let's just let y equal that. It makes life easy for the notation. So dy by dx will equal 8x cubed differentiated times by 3. 8 times 3 gives me 24. X, take 1 off the power squared. I've got a minus here. 2 times minus 12 gives me minus 24x. And I've also got this differentiator just gives me plus 6. And the minus 1 disappears. So let's take 6 out as a factor. That'll make our life a bit easier, because 6 goes into this, this, and this. So 6, open brackets, I've got 4x squared minus 4x plus 1 when I factorise this. 6 into 24 goes 4. Don't forget your squareds. Now that equals 6. Now let's put that into brackets, and we can see that this is just going to be the same as this. 2x minus 1 all squared. 2x times 2x gives me the 4x squared, minus 1 times by the 2, and the 2x times the minus 1 will give me minus 4x, minus 1 times minus 1 gives me plus 1. So this is just the same thing. So we've shown that no matter which way we do it, we get the same answer. But actually, as you get quicker, you'll be able to see how to do the chain rule differentiation in your head, and that will lead to quicker answers than multiplying out. So we know these are equivalent. And let's just have a look at how we might do y equals 2x minus 1 all cubed in our heads if we could. So I'm going to have a look at y equals, open brackets, 2x minus 1 all cubed. Now basically, if you can imagine covering up bits of this. So if I just highlight the bit I'm talking about, so I can imagine covering up the 2x minus 1. I'm going to leave it there so you can just about see it, as long as you've got good eyes. Okay. Now, if I differentiate that, if I just imagine differentiating that thing cubed, then I'm going to get equals times by the power 3, and I'm going to get something to do with that thing squared. Now I also got to differentiate what's inside this thing. So differentiate what's inside this thing. 2x minus 1 gives me 2. I'm going to end up timesing by that. So you imagine it being thing to the power of 3 differentiated gives me 3 thing squared. Differentiate the thing gives me 2. And therefore I get 3 times thing to the squared times 2 gives me my chain rule. So that is essentially how you go about doing a chain rule without having to write out all the notation to do it. You can just do it in your head like that. So just imagine covering up whatever's inside the function, differentiate this as if it was whatever this thing is, a u or a g or whatever you want to call it. Just I'm going to say thing cubed, so you get 3 thing squared. Now differentiate the thing, and you get times by it, and you get times by the 2. 2 times 3 gives you 6, and you get your answer that way by doing it in your head.